Okay, so you're doing your walk around, you glance at the display, and there it is. Check alarm. Specifically, alarm code 11.
Unit controlling on alternate sensor.
Exactly. Now, for a lot of people, any alarm feels like a full-blown crisis. But this one's a bit different, isn't it?
It is. It's the unit basically telling you, hey, I'm hurt, but I'm still on the job. Code 11 is really a failsafe. It means the main way it controls temperature has failed, so the controller has switched over to its plan B.
To save the load, which is a brilliant piece of redundancy.
It is.
So today, let's do a deep dive into alarm code 11. We need to look at the logic behind that sensor switch, the very specific order of operations for clearing it, and why just swapping a part isn't really the full story.
Yeah, you really have to look at the data. But to get there, you first have to understand how the controller is supposed to think.
Its normal state.
Right.
Yeah.
Under standard operation, the unit uses a primary sensor. Usually that's the return air sensor. It's measuring the temperature of the air coming back from your cargo.
And that tells it how much cooling it needs to do.
Precisely. But if that sensor fails, if it shorts out or the reading goes completely haywire, the unit can't just fly blind.
No, it would probably just shut down on a safety fault otherwise.
It would. So instead, the controller triggers code 11 and automatically shifts its point of reference. If the return air sensor fails, boom, it starts controlling based on the discharge air sensor.
Okay, but that's a huge shift in how it operates, though.
Yeah.
It's no longer watching the air from the load. It's now watching the air that's just leaving the evaporator coil.
The control logic is completely different. It keeps the unit running, which is priority number 1, but you're now managing the temperature of the airstream, not the box itself.
And I assume it works the other way, too.
It does. If a unit is set for discharge air control, which you see in some, specialty pharma or produced loads, and that sensor fails, it flips right back to the return air sensor.
So it buys you time. It gets you to a shop. But this brings us to the actual diagnostics. Because like you said, code 11 is almost never traveling alone.
It's the messenger. If the controller had to make that switch, there has to be a reason, and you're going to find its partners right there with it.
You're talking about alarm code 03 or 04.
Yep. You'll almost always see either alarm code 03, check return air sensor, or alarm code is 04, check discharge air sensor, active at the same time. Those are your root causes.
And this is where I see technicians get stuck. They see code 11, they fix the sensor, they want to clear the alarm from the dashboard, but the system it won't let them.
It's a hard interlock in the logic. Code 11 is a manual clear alarm, but the controller is programmed to forbid you from clearing it while that underlying sensor fault is still active.
So you can't clear 11 if 03 or 04 is still there.
You just can't. The workflow has to be precise. You find the failed sensor, you repair or replace it, you clear the sensor alarm first, the 03 or the 04, and then only then will the system let you clear code 11.
Fix the root, clear the root, then clear the backup alarm.
That's the sequence. The only slight exception is if alarm code 12 sensor shutdown is set. That can sometimes auto clear, but that's an edge case. For what you see in the field, you have to respect that order.
Okay, so here's the thing. The unit saved itself. The driver might not have noticed the failure for hours. The display says check alarm, but the box is still holding temp. That creates a huge blind spot.
A very big one. You don't know when the switch happened or what the temperature did during that transition, and that's why you can't just stop at the dashboard. You have to plug in.
This is where Service Watch comes in.
This is exactly where the Service Watch, Data Logger, and WinTrack software are critical. You have to download that data.
You're looking for the timeline, the story of what happened?
Yeah, you open it up under the technician user level, and you get this high-resolution view of everything. You can pinpoint the exact second the primary sensor flatlined or started to drift. You can see if the temperature spiked before the switch.
Or if the unit started short cycling once it moved to the other sensor?
All of it. It moves the job from just, I swapped a part, to, I have verified the integrity of this load.
Because the Service Watch data actually freezes the conditions at the moment the alarm was set.
Right.
And when it was cleared.
It does. It lets you confirm the failsafe worked the way it was designed to and that the cargo wasn't compromised during that little handoff.
It really highlights the difference between a unit that's just running and a unit that's actually performing correctly. Code 11 keeps you running, but the data tells you if you performed.
You know, we tend to think of history logs as this dusty archive we only look at when something goes really wrong. But that data, it's a reconstruction of reality. It is the only way to see what the world looked like to that machine in the exact moment it decided to switch sensors to save its cargo.
The real skill isn't just fixing the wire. It's being able to read the story the machine wrote for you. That's a great place to leave it for this deep dive. Thanks for listening.